Hi, my name is Jocelyn Hathaway, and this video is for my History of Mathematics class, and the topic for this video is Indian mathematics. Indian mathematics emerged from 1200 BC until the 18th century. It was during the classical period that was from 400 AD to 1200 AD. Many of the concepts that were founded by the Indians were shared with other countries, and these countries included the Middle East, China, and Europe. By sharing these mathematical discoveries, this allowed the other countries to further develop the mathematical concepts. Also, all math was verbally shared until 500 BCE, and then after that, a written copy was available. During this time, they also had many mathematical contributions. This included decimal number system, the concept of zero as a number, negative numbers, arithmetic, and algebra. The first major contribution is the decimal number system. This number system was developed between the 1st and the 6th centuries AD. It can also be called the Hindu-Arabic or the Arabic number system. In order for a number to be a decimal number, it has to have 10 as the base and requires 10 other numbers from 0 to 9. Most times people think a decimal number has a decimal in it, but in order for it to have a decimal, it has to have place values for each of the numbers before the decimal point and after the decimal point. Numbers are also used to take different place values depending on the position. An example could be the tens place, hundreds place, or thousands place. In this picture, we have the number 2,537. Each number in this one number represents a place value. The 2 represents the thousands, the 5 represents the hundreds, the 3 represents the tens, and the 7 represents the ones. The process for this would be to multiply the 2 by its place, which is 1,000, the 5 by its place, which is 100, the 3 by its place, which is 10, and the 7 by its place, which is 1. Once all of these numbers are multiplied, you add them together to get the whole number. Their second discovery was the concept of zero as a number. The person that discovered this concept was Brahmagupta. He came up with a text to treat zero as a number rather than as a placeholder. He also came up with a set of rules for using zero. His rule was, when zero is added to a number or subtracted from a number, the number remains unchanged. A number multiplied by 0 becomes 0. The third major contribution was the idea of negative numbers. Negative numbers are any numbers that are less than 0. Negative numbers can also represent opposites. When it comes to numbers on a number line, such as the one in the picture, negative means to go to the left, while positive means to go to the right, while 0 will represent the origin or the starting point on a number line. This idea was also created by the Indian mathematician Brahmagupta. Similarly to what he did with 0, he created 11 rules for negative numbers. These rules were: a debt minus 0 is a debt, a fortune minus 0 is a fortune, 0 minus 0 is 0, a debt subtracted from 0 is a fortune, A fortune subtracted from zero is a debt. The product of zero multiplied by a debt or fortune is zero. The product of zero multiplied by zero is zero. The product or quotient of two fortunes is one fortune. The product or quotient of two debts is one fortune. The product or quotient of a debt and a fortune is a debt. And the product or quotient of a fortune and a debt is a debt. And a debt is a debt. The Indians also contributed to arithmetics. The main rules in arithmetics include addition, which is the yellow symbol, subtraction, which is the blue symbol, multiplication, which is the purple symbol, and division, which is the green symbol. Each of these also have a set of rules to follow. For addition, the rules include combining two numbers called the addends or terms into a single number to get the sum. The rules for subtraction mean finding the difference between two numbers or the minuend minus the subtrahend. The rules for multiplication include combining two numbers called the multiplier and the multiplicand to get a single number, which is the product, and these two numbers can also be factors of each other. Also, the last one is division, which rules include finding the quotient of two numbers or the dividend divided by the divisor. Another contribution made by the Indians was trigonometric functions and definitions. This includes sine, cosine, and tangent. These trigonometric functions were created by mathematicians at the Kerala school in the 15th century. The Kerala school is located in New Delhi, India, and it is the school of mathematics and astronomy. This school was founded by Madhava and included 7 members at the time. This school flourished between the 14th and 16th centuries. Two of their main contributions along with these trigonometric functions included the infinite series in calculus and the mathematical induction proof. The first trigonometric definition is the law of sines. This states that A over sine A equals B over sine B equals C over sine C. Also, by using this, you can see that the formula creates an equilateral triangle having equal sides. The second trigonometric definition is the law of cosines. This could be stated in two ways. The first is cosine C equals A squared plus B squared minus C squared all over 2AB, or the second one, which states C squared equals A squared plus B squared minus 2AB times cosine C. The third trigonometric definition is the law of tangents. This states that A minus B over A plus B equals the tangent of 1/2 times A minus B all over the tangent of 1/2 times A plus B. For these trigonometric functions, they can be used for almost any triangle. In particular, they are often used for right triangles and follow the rule of SOHCAHTOA. SOHCAHTOA means for SOH, sine of your angle equals the opposite over the hypotenuse. The CAH means the cosine of your angle equals the adjacent over the hypotenuse, and the TOA means the tangent of your angle equals the opposite over adjacent. Also, when following the rules for using this on a triangle, your hypotenuse will always remain the longest side of your triangle, and the opposite and adjacent will be the other two sides, depending on where your angle is. The three major scholars that I found contributed to Indian mathematics were Aryabhata, Brahmagupta, and Bhaskara. Brahmagupta was born 476 AD in India and died 440 AD in India. He was the first major mathematician and astronomer in Indian mathematics and astronomy. His major works included the Aryabhatiya and the Arya-Siddhanta. Brahmagupta was the second major Indian mathematician. He was born 598 AD in India and died 670 AD in India. He was an Indian mathematician and astronomer and was responsible for creating zero. The third and final major contributor to Indian mathematics was Bhaskara II. He was born 1114 in India and died 1184 in India. Like the other two contributors, he was an Indian mathematician and astronomer. He was mainly responsible for creating the decimal system. By researching about the types of mathematics, I found that it is important because mathematics is very universal. It can be used in many subjects such as the sciences and computer sciences. Not only is it important to learn basic math, but it is also important to know different formulas depending on the job or occupation that you have. This includes telling time, keeping score, your probability and chances in different situations, life skills, spending money, making money, investment, management, teaching, and researching. Mathematics continues to grow as we get older and move to higher grade levels in school. This is true due to the fact that I am a mathematics major. I can see that many of the mathematical discoveries are used in my classes today, and I continue to use them interchangeably in my math and science classes. Even though there are some rules in mathematics that will not change, there are still many equations that have not been solved and discoveries to be made. The Millennium Prize consists of unsolvable mathematics equations. This list of problems was created at the Clay Mathematics Institute. In total, there are 7 mathematics problems on the list. In 2003, one of the problems was solved by a Russian mathematician. As of this year, 6 of the problems remain unsolved. With the use of the mathematical discoveries that have already been made, it is possible to solve one of the unsolvable mathematics problems. After researching about Indian mathematics, it is easy to say that These discoveries can be used in any types of mathematical problems or equations.